JMath.
In this video, we're going to look at the graph of the derivative and how it relates to the graph of the original function. So I think you've noticed that every time we do a cubic function, it's an x to the power 3. And then when we do the derivative, then it is an x to the power 2. So what I mean with that is, let's say my original function was 3x cubed, then the derivative would be 9x squared. Now, anything cubed is a cubic graph, and anything squared is a parabola. And that's what you see on screen here. But how does it relate to each other? When fx has a stationary point, the derivative has an x-intercept. So remember from when we sketched the graphs, to find a turning point, we make the derivative equal to 0. So whenever there's a stationary point, the derivative will have an x-intercept. And whenever f has a point of inflection, that is the turning point of the parabola or of the derivative. So that's the dotted lines you see on these sketches. Okay, now something else that's also extremely important, and we also discussed that previously, is when the derivative is positive, then the original is increasing. And the flip side of that, when the derivative is negative, then the original is decreasing. You will get questions on this, but it's not as prevalent as other types of questions like getting the turning point and sketching and those things. So in every 3 exam papers or something, you'll get one of these, but you still need to know how to do it because it is part of the syllabus. So let's go a bit deeper into this and answer a few questions. In this first example, they give me the graph of the derivative. So I can see the formula x squared minus 6x plus 5. In question A, they ask me draw the original on the same axis. Okay, now, if you get a question like this, it will be called a rough sketch because they're only going to mark the x values of your key points because we don't know the y values. Now, what we saw in the previous slide, whenever the derivative has a x-intercept, then the original has a turning point. So what I'm going to do is I'm going to draw a vertical line on each of the x-intercepts. Yeah, because then I know that the original will have turning points there, but I don't know the shape of the original. So now I need to see when the derivative is positive, so this section here to the left, then the original is increasing. When the derivative is below the line, the original would be decreasing. So that means left of the purple line, my original goes up till it touches that line, and then it must be decreasing all the way till it touches the other purple line. And then it is increasing after that. So that is the shape they want me to draw. They are only going to be interested in where's the turning points. Okay, which one is higher and which one is lower, so that they can see if you understand the increasing and decreasing parts. So that's the answer for question A. It would be 2 or 3 marks. Question B, find the equation of fx. Now, if you know people that take AP Math, or if you take AP Math yourself, then they do that a lot. But in normal maths, you don't really get taught how to do this, but it has been asked in some exam papers. So let me show you how. There's 2 main ways, but let's discuss both, and then you can choose which one you like. So the first way, and that's the one they teach you in AP Math, is to go anti-derivative. So you now know the power rule. The anti-derivative just means we're going to do it in reverse. So with the power rule, if we have ax cubed, we would say take the exponent, multiply by the number in front, and then minus 1. And that's why it would be 3ax squared. Okay, now we're going to do that in reverse. So we are first going to plus 1 to the exponent and then divide the number in front. Let's do that with this specific question. So for the first term, if I have x squared, I'm going to plus 1 to the exponent. That would make it a 3. And then I'm going to divide the number in front by 3. Okay, so it was a 1, and now I'm just dividing it by 3. The next one, so there's a 6 and an x. There was a 1 exponent. I'm going to add 1 to that, so that becomes a 2. And then I'm going to divide the number in front by that 2. With the last one, there was an x0 there. So I'm going to say this is 5x. I'm going to add 1, and then I'm going to divide by 1. Now, we don't know what the d value was. So I'm just going to put a c there for constant. Okay, so now if I simplify, therefore, fx would be equal to 1 over 3 x to the power 3 minus 3x squared plus 5x plus c. Okay, great. So that is the original. I just don't know what the d value is, but in questions, they will sometimes tell you what the d value is, and sometimes they won't. Then you just put a c there. So that's the first method, anti-derivative. Now, if we go with power rule with all of these, I assure you it will get back to the green graph that we have up there. But the other way is called the inspection method again. So we've done a few inspection methods already, but for this specific type of question, it's called the inspection method again. So what I would do in this method is take the original purple equation, and I would do the normal derivative with a's, b's, c's, and d's. So what that means is if I derive the purple one, it would be 3ax squared plus 2bx plus c. Okay, the d doesn't have an x, so it does not go to the derivative. Now I'm just going to link up all the corresponding parts that go together. So 3a goes with the 1, 2b goes with the minus 6, and then c would be 5. So to solve this, I can say, therefore, 3a must be equal to 1, and therefore a is equal to a third. 2b must be equal to minus 6, and therefore b is equal to minus 3. Then 5 is equal to c. So therefore, my original purple equation I can rewrite as 1 over 3 x cubed minus 3x squared plus 5x. And then once again, I don't know what d is, so I can just put a variable there. Like I say, you won't get asked this many times, but it has been asked, I think, twice in the last 5 years. So you just need to know. Keep it in the back of your mind. That's how you would do it. Question 2. In the diagram below, the graph of the derivative is shown, where the original was ax cubed plus bx squared plus cx. And that represents a cubic function. Question A. For which values of x does fx have a stationary point? So remember, the original always has a turning point when the derivative has an x-intercept. So I can see at -1 and at 5 are the x-intercepts of the parabola. So therefore, those are the x values of the turning point of the original. So my answer would just be x equals -1 or x equals 5. Question B. For which values of x is fx increasing and decreasing? Okay, so when the parabola is above the line, the original would be increasing. And when the parabola is below the line, the original would be decreasing. So I can say it increases when x lies between -1 and 5. It decreases when x is less than -1 or when x is greater than 5. So it decreases twice and it increases once, meaning it would be a shape like that. But we're going ahead of ourselves. Question C. Explain why fx has a local minimum at x equal -1 and a local maximum at x equals 5. Now, don't get worried about the local this and the local that. The minimum just means out of the two turning points, that is the lower one, and the local maximum that's the highest one out of the 2 points. Remember, a cubic graph goes on forever, and we just normally see the little part where the 2 turning points are. So that's why they call it a local maximum, because they know the graph goes up way past whatever the turning point is, but out of the 2 turning points, that's the highest one. Now, if I look at this sketch, I know that the turning point would be somewhere on that line, and the other turning point would be somewhere on that line. Now, they're not asking me to sketch this, but for me to explain to you what's going on, a sketch is always the easiest. Now, I know left of the first purple line, my graph must be decreasing because the gradient, the derivative, is negative. It's below the line. So that means this graph goes down until it touches this line. Then between the 2 purple lines, the graph must be increasing because the parabola is above the line and the gradient is positive. And then after the next purple line, it is decreasing again because the parabola goes below the line. And that's why the first one is a local minimum and the next one is a local maximum. So to answer the question, I'm just going to write it on the side because there's more space, is when x is smaller than -1, fx decreases. Then you can say when x lies between -1 and 5, fx increases, and when x is greater than 5, fx decreases again. Then I can just say, therefore, x equals -1 is local minimum, and x equals 5 is local maximum. So if they see that you know when it's increasing and decreasing, you will get your marks for question C. Question D, determine the equation of the derivative. So now I need to go back to grade 10 and 11 when we found the equations of a parabola. So I can see I have 2 x-intercepts, and I actually have the y-intercept. So I'm going to go for that method. I hope you guys still remember this one. Ax minus x1 and x minus x2. I can sub in x1 and 2 already, so that would just be -1, and that would be 5. Now I'm looking for another point that I can sub into x and y, and I'm going to take 15 and 0. The goal is now to figure out what's a, and I can see this is a -5 and then 15. So therefore, a is equal to -3 in this case. Now I go back to the first step and say, okay, if I know that a is -3, I can FOIL out those 2 brackets, and that gives me x squared, and then plus 1x minus 5x gives me -4x minus 5. If I times in the -3, I am going to get -3x squared plus 12x plus 15. Okay, great. That is the answer for this parabola. Question E, for which values of x does fx have a point of inflection? Okay, so remember, the point of inflection is always the same x value as the turning point of the parabola. Okay, so I can immediately just see the answer is x equals 2. But that is not good enough. Let me show you how you would work it out. So we now saw that the equation of the derivative is equal to -3x squared plus 12x plus 15. Okay, now the double derivative is always linked with the point of inflection. So when I make the double derivative equal to 0, I'm going to get x is equal to 2. So let's do that. So -6x plus 12 equals to 0. So 12 equals to 6x, and therefore x is equal to 2. Now this question, if they give you the sketch, would be 1 mark. So you can literally just write down x is equal to 2, because I can see that's the axis of symmetry of this graph. But if you want to show a calculation, this is the calculation that you would need to show. Remember, they didn't ask me for the y value or the coordinates, so I don't need to go sub this in. The answer is literally just x equals 2. F, determine the equation of the original. Okay, so like we just did in the previous slide, there's 2 ways to do this. I'm going to take the long way, but you can do antiderivative if it makes sense. I am just doing the one that most people like more. So remember, I start this by writing out the generic cubic formula. And luckily in this question, they gave it to me up there. And another good thing is I can see there's no d value in the original equation that they gave me, so I don't need to worry about the constant at the end. So I start by writing down that formula. Then I'm going to derive that formula with a's, b's, and c's. So for this one, the derivative would be equal to 3ax squared plus 2bx plus c. And now I must just relate it to the derivative formula that we found in question D. So with this one, I can see that 3ax must be equal to minus 3. I can see that 2b must be equal to 12. And I can see that c is just 15. And now I can just write that down for them and solve. So 3a is equal to minus 3, therefore a is equal to minus 1. 2b is equal to 12, and therefore b must be equal to 6. And c is just equal to 15. So to answer the question, what is the formula of f? I can say, okay, so fx must be equal to minus x cubed and then plus 6x squared plus 15x. That's it. I don't think this method is too difficult. I like this one more than the antiderivative because it's much easier to understand. Question G, for which values of x is the gradient of fx increasing and decreasing? Now watch out for this question. It's not the same as question B, where they just ask where's fx, where's y increasing and decreasing. They're asking for the gradient. Now remember, the gradient is the derivative. So the derivative is increasing for all the values left of 2, which is the turning point of the derivative. So everything left of this green line tells me that the derivative is increasing and therefore the gradient is increasing. So my answer there would just be x smaller than 2. Whereas m decreasing, obviously then just x greater than 2. So watch out, one word can change the entire question. Don't let them catch you out. Question H, for which values of x is fx concave up or concave down? Now there's many ways to answer this question. If you have the original sketch, then you know it is just, if I split the graph on that dot, the happy face is concave up and the sad face is concave down. So I don't have the original sketch. I can make a rough sketch because I know the dot is on 2, but I'm going to go a different way with this question. So a fail-safe way to do this, that you don't take chances with sketches and misunderstanding something, is just it's concave up if the double derivative is positive, and it's concave down if the double derivative is negative. So let's get the double derivative first. So I can see there is my equation for the derivative. So therefore the double derivative would have an equation of minus 6x and just plus 12. Okay, so now I know it's concave up when the double derivative is positive. So I'm just going to do a little inequality, greater than 0. So minus 6x must be greater than minus 12, and therefore x must be smaller than 2. Remember, if I divide by a minus, I must flip the inequality, always. So therefore, it's concave up when x is smaller than 2, and then the inverse is then just x is bigger than 2, would be where it's concave down. Okay, guys, so these are the type of questions you can expect if they give you a derivative graph instead of the original. So please just go back to sections that wasn't clear to just look at it slowly and try and figure it out yourself. Let's do another example. Question 3, in the diagram below, the graph of the derivative is shown, where fx equals just my standard form, but I can see there that the y-intercept is 0, so there's no d in that formula. Represents a cubic function. Question A, determine the x-intercepts of the turning points of fx. Okay, so not this turning point, because that's the derivative. They want the turning point of the original. So now, just as we've discussed in this video, the turning point of the original is always linked to the x-intercepts of the derivative. So I can see the x-intercepts are 0 and 6, and that is the answer for question A. So x is equal to 0 or x is equal to 6. So at this stage, I really don't know what the y values are, but that's not what they asked me, so it's fine. Question B, determine the equation of the derivative. So it's a parabola, and I can see the turning point, but I can also see the x-intercept. So I have two options to go here. I'm going to stick with the x-intercept formula that we used earlier. So y is equal to a, and then x minus 0 and x minus 6. Now, I can sub in the other random dot that I have. So I can say this is 2 if that is a, and then 3 minus 0 is just 3, and 3 minus 6 is just minus 6. So 2 is equal to minus 9a, and therefore a is equal to 2 over negative 9. I'm just going to put the minus in front. Okay, so then to finish off this question, I can sub back into the first step. So just there, and this is minus 2 over 9. The first bracket is just an x, and then x minus 6. And now I can just distribute into the bracket. So minus 2 over 9x squared, and then that would be plus 12 over 9x. So in simplest form, this would then just be y is equal to minus 2 over 9x squared plus 4 over 3x. Question C, if it is given that if I sub in 3, the answer is 4, and if I sub in 6, the answer is 8. Sketch the graph of f. So now first thing you're going to do is convert this to coordinates. So because I'm subbing into the original, that is just x and y. If it was subbed into the derivative, then it's a whole different story, but that's not what we have here. Okay, so those are two coordinates. They're asking me to sketch the original on top of the derivative. So I can go and make those two coordinates already. So I know when x is 3, y is 4, so I'm going to have a dot there. And then when x is 6, y is equal to 8. I also know, because of the hint they dropped above, that my y-intercept would be on 0 and 0. So there I have 3 dots. Now I just need to figure out the shape of this graph. So to do that, I know my turning points are at 0 and 6. So I'm just going to do a straight line there and a straight line there. Okay, now I need to interpret what the derivative tells me. So left of 0, the derivative or the gradient is negative. That means the original graph is decreasing. Between the two lines means that the graph is increasing because the parabola is above the x-axis. It's positive, and therefore the original graph must increase. When x is greater than 6, my derivative is below the x-axis, so then the original must be decreasing. So that tells me the original will start high, go down till it reaches the y-intercept of 0, then go through the 3 dots all the way up to 8, and then it would decrease again. And for that, I will get full marks. Just make sure you write that that's the original. Okay, guys, so this was a video on how the derivative relates to the original's graph. I hope it made sense. This is, in many cases, the deepest you're going to go into calculus. So just keep on practicing. Like I said earlier, it's not there in every single exam and test, but it is beneficial to yourself if you know how to do this.
If this video helped you, please like and subscribe.
JMath.